Overview. Magic Trace collects and displays high-resolution traces of what a process is doing. People have used it to figure out why an application running in production handles some requests slowly while simultaneously handling a sea of uninteresting requests. Look at what their code is actually doing instead of what they think it's doing. Get a history of what their application was doing before it crashed instead of a mere stack trace at that final instant, and much more. Magic Trace has 2% to 10% overhead, doesn't require application changes to use, traces every function call with about 40 nanoseconds resolution, and renders a timeline of call stacks going back about 10 milliseconds. You use it like perf, point it to a process and off it goes. The key difference from perf is that instead of sampling call stacks throughout time, Magic Trace uses Intel processor trace to snapshot a ring buffer of all control flow leading up to a chosen point in time. Then you can explore an interactive timeline of what happened. You can point Magic Trace at a function so that when your application calls it, Magic Trace takes a snapshot. Alternatively, attach it to a running process and detach it with Ctrl-C to see a trace of an arbitrary point in your program. Testimonials. Magic Trace is one of the simplest command line debugging tools I have ever used. Francis Ricci, janestreet. Magic Trace is not just for performance. The tool gives insight directly into what happens in your program, when, and why. Consider using it for all your introspective goals. Andrew Hunter, janestreet. I use perf a ton, and I think that both perf and Magic Trace give perspectives that the other doesn't. The benefit I got from Magic Trace was entirely based on the fact that it works in slices at any zoom level, so I was able to see all the function calls that a 70 nanosecond function was performing, which was invisible in perf. Doug Patty, janestreet. Install. First, make sure the system you want to trace is supported. Constraints that most commonly trip people up are that virtual machines are mostly not supported, it is Intel only, Skylake or later, and Linux only. Second, grab a release binary from the latest release page. If downloading the pre-built binary, run chmod plus x Magic Trace. If downloading the package, run sudo dpkg-i Magic Trace deb, then test it by running Magic Trace -help, which should bring up some help text. Getting started, here's a sample C program to try out. It's a slightly modified version of the example in man3dlopen. Download it, build it with gcc-demo.c-ld.o demo, then leave it running /demo. We're going to use that program to learn how Lopen works. Run Magic Trace attach -pid of demo. When you see the message that it's successfully attached, wait a couple seconds and Ctrl-C Magic Trace. It will output a file called tracefxt.gs in your working directory. Open magictrace.org, click Open Trace File in the top left corner, and give it the trace file generated in the previous step. That should have expanded into trace. Zoom in until you can see an individual loop through Lopen, lsim, cos, printf, and close. W zooms into wherever your mouse cursor is pointed, S zooms out, A moves left, D moves right, and the scroll wheel moves your viewport up and down the stack. You'll only need to scroll to see particularly deep stack traces. It's probably not useful for this example. Click and drag on the white space around the call stacks to measure. Plant flags by clicking in the timeline along the top. Using the measurement tool, measure how long it takes to run calls. On my screen it takes about 5.7 microseconds. Congratulations, you just magically traced your first program. In contrast to traditional perf workflows, Magic Trace excels at hypothesis generation. For example, you might notice that taking 6 microseconds to run COS is a really long time. If you zoom in even more, you'll see that there are actually 5 pink untraced cells in there. If you rerun Magic Trace with root and pass it, trace -include -kernel, you'll see stack traces for those. They're page fault handlers. The demo program actually calls COS twice. If you zoom in even more near the end of the 6 microseconds COS call, you'll see that the second call takes far less time and does not page fault. How to use it? Magic Trace continuously records control flow into a ring buffer. Upon some sort of trigger, it takes a snapshot of that buffer and reconstructs call stacks. There are 2 ways to take a snapshot. One is just to Ctrl-C Magic Trace. If Magic Trace terminates without already having taken a snapshot, it takes a snapshot of the end of the program. You can also trigger snapshots when the application calls a function by passing Magic Trace the trigger flag. Trigger ? Brings up a fuzzy finding selector that lets you choose from all symbols in your executable. Trigger symbol selects a specific fully mangled symbol you know ahead of time, and trigger dot selects the default symbol. Magic Trace stop indicator. Stop indicators are powerful. If you're using an asynchronous runtime, Anytime a scheduler cycle takes too long, in a server, when a request takes a surprisingly long time, after the garbage collector runs, to see what it's doing and what it interrupted, after a compiler pass has completed, you may leave the stop indicator in production code. It doesn't need to do anything in particular. Magic Trace just needs the name. It is just an empty, but not inlined, function. It will cost about 10 microseconds to call, but only when Magic Trace actually uses it to take a snapshot. Documentation. More documentation is available on the Magic Trace wiki. Discussion. Join us on Discord to chat synchronously, or the GitHub discussion group to do so asynchronously. Contributing. If you'd like to contribute, read the build instructions, set up your editor, take a quick tour through the code base, then head up the issue tracker for a good starter project. Privacy policy. Magic Trace does not send your code or derivatives of your code, including traces, anywhere. MagicTrace.org is a lightly modified fork of Perfetto, and runs entirely in your browser. As far as we can tell, it does not send your trace anywhere. If you're worried about that changing one day, set up your own local copy of the Perfetto UI and use that instead. Acknowledgements. Tristan Hume is the original author of Magic Trace. He wrote it while working at janestreet, who currently maintains it. Intel PT is the foundational technology upon which Magic Trace rests. We'd like to thank the people at Intel for their years-long efforts to make it available, despite its slow uptake in the greater software community. Magic Trace would not be possible without Perf's extensive support for Intel PT. Perf does most of the work in interpreting Intel PT's output, and Magic Trace likely wouldn't exist were it not for their efforts. Thank you, Perf developers. MagicTrace.org is a fork of Perfetto, with minor modifications. We'd like to thank the people at Google responsible for it. It's a high-quality code base that solves a hard problem well. The ideas behind Magic Trace are in no way unique. We've written down a list of prior art that has influenced its design. Footnotes. Perf can do this too, but that's not how most people use it. In fact, if you peek under the hood you'll see that Magic Trace uses Perf to drive Intel PT. Strictly speaking, anything newer than Broadwell, but this is not a platform we regularly test on, and timing resolution is worse. https link tractions upload artifact issues 38.